Hello, everybody. My name is Gregor Pipan, and I will be hosting you today together with my colleague Klemen Ozimek at the webinar Road Reconstruction Design and BIM Data. Let me say just a few words at the beginning. The webinar is recorded, and the recording will be shared with you later on. And you're also welcome to post questions during the webinar. For this purpose, you can find the section in the webinar dashboard. Please type your questions there, and we will try to answer them at the end of the webinar so that we don't disturb the webinar flow. Let me say just a few words now about CGS Labs and our product portfolio. CGS Labs is an IT company that is dedicated to the digitalization of the built environment. We develop solutions for the design, construction, and maintenance of transportation infrastructure. We have been around for more than 30 years. We also have a very strong environmental department where we develop, for example, road weather information systems to help winter maintenance services. And we're involved in the development of BIM and building smart activities and contribute to development of standards in the field of digital infrastructure design. CGS Labs civil solutions cover three main civil engineering fields. This is road infrastructure design, railway infrastructure, and river channel engineering design. Today, we will focus mostly on road infrastructure design, where we have three products. First is PLATEIA, which is kind of a complete solution for BIM-ready solution for roadway design and reconstruction. It's an all-encompassing solution for geometry design, for data management, for volume calculations, and various analysis, which you will see in the webinar. And then we have two smaller solutions. One is AutoSign, which is traffic sign and road marking design tool. And then we have also AutoPath, which is swept path analysis and vehicle turning simulation software. In the railway design category, we have Ferrovia, a complete solution for railway design and railway maintenance. And then we have also Aquaterra, a solution for channel design, river engineering design software. Today, focus of today's webinar is on PLATEIA, which is, as mentioned, a BIM-ready solution for road design. Today, we will focus on reconstruction design, part of the software. It is a very intuitive software because it is designed to follow the practice in civil engineering design, which is already established, and the software can be used for all design stages from preliminary to detailed design. Main software advantages, there are several, but today let's mention mostly that it is for all project stages, and you can design new roads and road reconstructions, which you will see further in the webinar. Areas of application are also very extensive. Today we will focus on road design, but as you can see, it can be used from various bicycle paths, tunnel design, or maybe even for earthworks calculations and so on. PLATEIA has been used or is in use by small and big companies all over Europe, Middle East, even in Africa. So we have quite a lot of international references and to mention is that PLATEIA is localized in several countries, so this means that it's translated, but it supports also local design standards, which is very important for the designers. Now I would like to invite my colleague, Klemen Ozimek, who is a technical specialist for infrastructure software at CGS Labs, to show you in practice how PLATEIA is used for designing road reconstructions. Klemen, please take over.
Hello, hopefully you can hear me. Okay. So thank you, Gregor, for your introduction. So again, my name is Klemen Ozimek and I work as a technical specialist at CGS Labs. Today we will take a look at the topic of reconstructions and BIM data. So in this technical part of the webinar, I will show you the approach and some useful tools to help you with your projects using PLATEIA. So let's just get into it. So first things first, here we have a basic list of what we will show you today. This will represent some of our design steps in our project. So if we start with the first point, we need some input data on which we can work. So for that we can use survey points or any other information such as point cloud. For example, today we will use survey points and we will just briefly mention point cloud because this can be a topic of itself. In the next step, we need to create a longitudinal axis and sample line or cross axis. We need to get the correct widths of the road lanes and the heights of the road edges so that we get the existing road or the real situation into our project in PLATEIA. Then we need to define the super elevations as they are on the existing road. And then we can also define the vertical alignment, which we can lower or raise as we need. Then we can also define the thickness of the new layers, from which we can also get automatic calculations of volumes. For the last part, we can create a 3D model with the cross sections and also attach it with some property sets to make it a BIM model. Let's go to our first point. So first and one of the most important steps of our project is getting the information we need to plan out our new road design. For that we need elevation points. We can use CGS points, which are basically blocks with additional information or attributes. This can be filled with various different information, such as which point represents an axis, which point represents an edge, and also some other information, such as which points group together into the same sample line, and maybe some graphical representation in the plan view and also in the cross sections. Then for majority of the projects, we create a digital terrain model, but in PLATEIA, we also have this possibility to drape directly onto the points, so we don't need a DTM to drape our alignment. So for each of these steps, we will take a look at a quick video recording to see how this step is done. For example, this is for inputting the survey points into the PLATEIA. So here we have quickly all these points with the information of the height and the name of or ID of the point. Here we can also show some other information that we imported, such as cross-section and cross-section symbol. As you can see, we get other information that we already had it before from the surveyor. Maybe one thing we can also do now at this point is just to make a quick pull question. So Gregor, if you will help me out here, I think we have the pull questions prepared. So here we just want to see how much of your projects are basically reconstructions. Okay, so as you can see, almost everyone works with reconstructions and quite regularly. Okay, maybe now we can move from points to our alignment creation. So let's go to our next slide here. So we can create the longitudinal axis with different methods. Of course, we can draw a new axis with the PLATEIA commands such as tangent, polygon, floating elements, and stick method. We also have some convert possibilities, but in this case we will use the best fit method. This will give us the best approximation of main elements through the desired points or point attributes without actually drawing them manually one by one. So we have this best fit alignment window, and we will also get the report and our alignment. Let's just go to our video. So we use create best fit alignment command. Here we can use one string or two strings of input data. So depending, or do we use only the axis or the edges? We can use polylines or points, and we also define the alignment direction and the name. So here it will calculate the best fit for these points. Here we also get the draw lines window and some warnings if the elements are not according to the standard for this road type. At the end, we get the report. We see all the maximum offsets and the average offset. Here we can move through the points and see where the offset is the biggest. And we can also edit the alignment as we want. We can use the edit alignment in tangent polygon command and change the radiuses and the spirals as we wish. For example, here we will remove this line in between and just make spiral a little bit bigger. And we can edit this alignment on the whole section without actually drawing all the elements one by one. Let's say we are okay with this and we move to the cross-axis or the sample lines. Sample lines can be created by using CGS point attributes, as we did before. Here we can choose different methods for connecting these points. So usually we use the perpendicular method so that the sample lines are perpendicular to the longitudinal alignment. These sample lines can also be draped directly onto the points instead of needing a digital terrain model. So let's see this. So we use create sample lines from points. We choose the layer, so we can have the points on some other layer, and we choose the perpendicular regression. Then we can also change the width left and right. So because we don't have that many points, we can just make it smaller. And we also get all the names for the sample lines directly from the points. Then we can drape this. So if we look at it in the 3D view, we can see all these green 3D polylines that represent our actually cross sections and longitudinal section. Now that we have the cross section and axis, we can move and make road lanes or edges. Same thing here, we can use the point attributes to connect all the points with the lines. We can use different tools here. So for example, we have some tools in site design to work with polylines. And also we can make 3D lines based on 2D data and elevation information. So let's check this. So now that we have, first we will erase the lanes that we have. So these ones were made from the projects and they are not correct. We want them to go through the points that we recorded. So we will search for points that have attribute right edge, and I will select all of them and give it to the selection, AutoCAD selection, and I will move to the site design ribbon and use polyline from points command. Here I can quickly create a polyline, 3D polyline through all of these points, and I will again use the same thing but just on the left edge of the road. So I choose all the left edge points and connect them with our site design tool. And here I have quickly made all the road edges. So that PLATEIA recognize the widths of the lanes, they need to be in 2D. So I will flatten those edges and we will move them to the correct layer, the ones that the PLATEIA will recognize. And here I have them in elevation 0, but I still want those road edges on the correct heights as we had before for the super elevations. And here I can use some other command. For example, I will use these lines and the points, and it will create me break lines again on these elevations of the points. So here I got all the information that I need for the next steps. So here we will define the existing super elevations. Here we have two options by using cross sections or 3D polylines. With cross sections, if you use that method, we must first save a file Within it, we can define which points are our road edges and which is the center line. Or we can also use the 3D polylines that we have in our plan view and define them that way. So let's see both methods. So first thing we need to do is to draw a longitudinal profile view just to get these rubrics. And I will move to the layout tab and save the cross sections into a file. These are the green 3D polylines that we draped before. So now that we save this file, we can import it back with as super elevations. Here I can define other attributes if I want, and I will get the existing super elevations. These are only temporary now, but I can make them active if I want, or if I want to use them as template, I can make our own super elevations. Okay, now I am converting these existing super elevations to active ones, and I get all the data, all the informations. So this was the first method. We can also check the second one, which is the 3D polyline. So again, here I have super elevations without any information, and I open the editor for super elevations. Here I can see all the section stations and the terrain line or the height of the road. And with the right button, I can click here super elevations from 3D polyline, and I will get all the values perpendicular to the axis. So again, here I define this, and here also I get user defined rubrics that maybe I don't want. These are the vertices of the 3D polyline. And as I can see in the window or the preview, here I can see that it's exactly as it is on the existing one. Here I can also change it in this editor, and I can manually write if I want to change anything. I just click apply, and this will all be written in the longitudinal profile view. Okay, now that we have our super elevations, we can go to our vertical alignment definition. Here we have some command for reconstruction. The command calculate new profile is intended to calculate points for a new vertical alignment. New points are calculated by raising or lowering the entire roadway of pavement. Here we also have volumes of wearing and base course, and they are automatically refreshed each time when the pavement height is changed. With defining these parameters, we can quickly change the height, and here we have some options to draw the reconstruction points or the tangents between the points. So let's check this. So yeah, the next part, when the reconstruction points are drawn, we can also make a best fit of the vertical alignment over these reconstruction points. Again, we get the report of the offsets, and we can also use our edit profile tools. So for example, we will use this reconstruction, calculate new profile after the super elevations are defined. And here I can define any thickness we want. For this example, I will just put everything to 0 so that it will stay the same as it was, as it is now. So I get all the reconstruction points on the terrain line or the recorded points on the road. And here I can use the best fit on the reconstruction points, which will get me the vertical alignment that I want. And I can change it again with our edit tools. So here again, I can see where the maximum offsets are, and I can change them as I want. For example, I can change the vertical curvature of these tangent points and change it as we wish. So for example, here we can also change the location of these points of our vertical alignment and make these edits. So this was like the part of reconstruction. Now we move to the cross sections, which we design as any other project. We actually design the new road layers, and from which we can also get the volumes. Based on this cross section, we can also create a 3D model. So for example, yeah, we have these cross sections with base, binder, and surface cores defined. And here we have a window for creating a 3D model. All the quantities here are read from the cross section, and we get the 3D model in our plan view. Let's take a look at how we do this. So we create these cross sections, and we can define the pavement layers. Here I will use another option that we have. So I will use the macro command. I have already defined those layers in the macro, and I will run it through all of those cross sections. So as you can see, all of our cross sections now have these pavement layers, so that we don't have to draw them one by one. Now we can move to the draw 3D model command and use all three layers to create 3D solids. So if we move to a 3D view and maybe change the visual style to something else like realistic or shaded, so we can have a better representation, we can see this 3D model. Now the next step is we can use this 3D model that we have and make it a BIM model. So what we need some information on these solids. For that, we have some tools in our CGS software, like this property manager and property set editor. Here we can define all the property set tables and attributes, and then attach them to our 3D solids. We also have an option to export to IFC and open it in some other viewer or other software. So let's take a look at this. So again, I will create a 3D model, use the same command, just that this time I will also select some property group on this quantity. And for example, I will use surface course. This one was defined beforehand, and when creating this 3D model, it will also add all these properties on the solids. Now, as you can see, we have this information. Some of them are automatic, some of them we can input ourselves, and we can add like multiple property sets to each of the solids. So then when we have that, we can export it to IFC and open it in, for example, BIM Vision. And here we can see all the properties that are added on these solids and all the information that we need. So to recap, I would like to go through the steps that I showed you today. So first things first, we imported the survey points that represent our existing road. We defined axes based on attributes that were on these points. So with the best fit command and the cross axis on the CGS points. Then we created road edges semi-automatically by connecting points with the same attribute. Then existing superelevations were defined by cross-axis or with 3D polylines. And then in the last step, we defined new road layers, draw the reconstruction points, and use the best fit for vertical alignment. Then after that, we defined the new layers in the cross sections. We used the macro command, and then we created the 3D model and attached it to it the property sets so that we made a BIM model. We have come to an end of this technical presentation. The project was done in BricsCAD, but I'm wondering what you're using as CAD platform. So I will ask Gregor to make another pull question, and I think you have some different option there. So this will be all from my part, and I'm giving the spotlight back to Gregor.
Thank you, Clement, for this very comprehensive presentation of reconstruction design. Let me continue. I'm sure that this presentation was very beneficial to all who are already using PLATEIA as their main design tool for roads. But if you're interested in trying out PLATEIA and you're using, for example, something else currently, or searching for a product, let me tell you that we offer a free trial, which is 14 days, and it is fully functional. You can request it on our web pages, and to support you during the trial, we offer several channels. You can use our technical support, which is live support by very qualified civil engineers. This is, of course, free during the trial. And then you can take advantage of our knowledge base online, which is always available. It has all the user manuals, videos, and cookbooks, and so on. We also have online basic trainings for all our main software, also for PLATEIA. Just go to our webpage and you will find it under the CGS Labs Academy. This is online self-paced training, so you can go through the training. It contains all the DVGs that you need, PDFs and videos. Now I would like to just check if there are any questions. We don't have actually have any technical questions. So if you have later on maybe questions regarding the product, do you need some commercial information or whatsoever, don't hesitate to let us know. Send us an email, call us, or call one of our representatives if there's available in your country, our partners that represent our software. At this point, I would just like to invite you to go to our web page, and at the very bottom of the page there is a link to the webinars, and you will find several other webinars that are specialized for civil engineers. They are for road design, for railway design, river engineering design, and just review them, and maybe you will find something that comes very helpful to you. And I would also like to direct you to some other resources that we have. We have lots of videos on our YouTube channel, how to use our software. The GoToStage is the channel for the webinars, and we also post a lot on LinkedIn and Twitter channels. There are lots of short, maybe tutorials that we post there. So I would like to invite you to follow us on our social media and get informed on the fly about our software. So to wrap it up, let me direct you to our webpage, cgslabs.com. And as mentioned before, if you have any questions regarding PLATEIA, regarding what Clement presented today on the webinar, or any other of our products for civil engineers, please let us know, send us an email. Yeah, thank you for today, and hope to see you on one of our next webinars for road designers soon. Thank you and goodbye to all.